Okay, let's get started. So different reading. This is, I think, our only reading that's out of, not out of the Moorcroft book, focusing on these systems archetypes in a little bit more detail than Moorcroft goes in some of his chapters. I think the start on the focus of the system that I think they begin with is kind of relates to this cartoon. And so this cartoon is a bunch of cars stuck in traffic. Let's see here if I can get this working here. And as the cars are sitting there stuck in traffic, each one of the individuals in the middle of the traffic is saying that if these idiots would just take the bus, I could be home by now. And so this is depicting a situation where it's best for every individual to take the highway, but it is best for anyone who's not that individual to do something else. And so we're kind of expecting the individual to not do what's best for the individual in order to improve the situation for other individuals who are doing the thing that is the most tempting thing to do. So what's the sort of archetype that we associate with this type of problem? You've probably heard about in a lot of your other classes. Yeah, in the back? Right, I would call this a tragedy of the commons. And this particular kind of cartoon example illustrates what we refer to as an open access resource or a common pool resource. And these resources are things that are characterized by two properties. One of them is they're non-excludable, which just means that any individual who wants to use the resource can for free. They can just go on and use the resource. You can't keep them out. In this case, a freeway at rush hour, anybody can go onto the freeway, you can't stop them. And they're rivalrous. Rivalrous means that when you have simultaneous users using the resource, the benefits that one person gets from using the resource are going to take away from the benefits that other people are getting from using the resource. And so whenever we have a sort of a depletable resource like this that has these two features, we refer to it as a common pool resource or an open access resource. And they typically are associated with this so-called tragedy of the commons. And it's a tragedy because the resource benefits are such that every individual wants to use the resource. And it will, if everyone else didn't use the resource, if one individual used the resource, that one individual would be better off. But because everyone is trying to be better off, they end up in a situation where no one is better off because so many people use the resource that the marginal benefit of the resource ends up being no better than how things would be if the resource didn't exist. That's the tragedy. You create a resource to make things better on an individual level, and everyone uses the resource because that's just a good thing for everyone to do. And in the end, the resource ends up being just as bad as things would be without it. And of course, there's a lot of other examples of tragedy of the commons. Fishing is the other model system that we often talk about, where if you go into an area where it's sustainable for one person to fish, there's nothing keeping a lot more than one person to fish. And so you end up getting overfishing, and you can't really criticize any individual because who's going to be the sucker here? Who's going to say, I'm not going to do that in order to make things better for you? That's really the trick of this tragedy of the commons is, how do you end up, for the highway example, you would have to have somebody saying, I think it would be quicker for me to take the highway, but just today for kicks, I'm going to go the long way because, why not? And that sort of altruism, there's no reason why you would expect a large number of people to do that. And so you end up getting these tragedy of the commons problems where we want to blame individuals, but really we can't blame individuals. The problem is with the system of how it's set up. And so in the case of fisheries, a common example for how you solve this thing is to say, well, let's not make it an open fishery. Let's actually go in and have government take over the fishery and charge fishing licenses. So like if you go to Kiwanis Park down on Baseline, and whatever that is, rural or college, they've got an area that people can go and fish freely, but technically you have to have a license to fish there, and that license restricts how many fish you can get out of there. So that is an example of putting a cost on it, so that it excludes everyone from fishing. And so taking away the non-excludable, making it an exclusive resource is one way you fix these sorts of problems. Rivalry, getting rid of that, that's hard to do, but that might be the cities constantly dumping more fish into the fishery so that when one person fishes, they don't notice a depleting effect for someone else. But that's extremely expensive to go and keep dumping and restocking the fishery, and it may not be possible. So now, those of you who've taken courses talking about Elinor Ostrom, how many people here have heard of Elinor Ostrom? Anybody? So she's really popular in the School of Sustainability, Nobel Prize winner, worked at ASU for a while. She has passed several years ago, and she studied systems in which the tragedy of commons was solved without, and just naturally among people, where small groups of people would come up with norms, that cultural norms that would naturally resolve these problems. And that's great in the systems where they work, but in very large scale systems, it's rare for those sorts of things to work, which is why you end up needing someone else to come in. So a lot of generalizable lessons that we can get by talking about fisheries and highways, which suggests that we could build a very generic model. And that's what we kind of talked about in the article, where we can model the basic problem with this causal loop diagram. And they have two parties here, A and B, but you can imagine a whole bunch of these. This is kind of like a spine with these sort of fins that are coming off of it. And they're only showing two fins, but you can imagine a player C that is sort of coming out of here at another angle, D another angle, and they would all look like these webs that are underneath here, these spines or fins that are kind of underneath here. And the basic idea, capturing the tragedy of commons, is that you have an individual, let's say B, and that individual is going to use the activity or use the resource, their activity, which is going to bring benefit to B, which is going to increase their activity. Like, oh, I got benefit out of that. So they will continue to use the activity. This is that reinforcing loop. However, as they increase their activity, that increases the total activity in the resource, which after some time is going to reduce the gains to each individual A and B, which through, and that's the O there, so that's the negative link, which will, the gain for the individual activity, that ends up being directly related to the net gains here. So if the total activity is reducing the gain per individual, it's also reducing the net gains for B. So in the short time scale, B ramps up their activity because it seems like that's getting better and better for them. But in the long term, because of this delay right here, then as B ramps up their activity, they're actually end up reducing the long-term benefit to them, because there's a bunch of other Bs out there. There's an A out there, there's a C out there who are doing the exact same thing. And that sort of captures this tragedy of the commons. So I was mentioning, what's one way we can break it? We can get rid of the rivalry. We can dump in more resources, so it's practically unlimited. So, and try to turn it into kind of a public good. And so a public good is like public radio. Anyone can listen to the radio and it doesn't affect anyone else. So it's like an unlimited resource that's out there. So we could just keep dumping fish into the fishery, or try to keep expanding the road. And maybe we can expand it fast enough that it'll be as if there's no limitation. That's probably not practical. Or we can attack the other side of it, which is make it excludable. So we can say that maybe A and B get access to it, but C does not. Well, how do we decide who's the C and who's the A and the B? A simple way to do that is to charge a fee for using the resource. And those who can afford the fee will use it, and those who can't will not. That's kind of a market-based solution there. And what that fee is could actually go up and down based on who's using the resource. So this sort of captures the kind of big problem here and allows us to think about possible solutions. And that was kind of the net message here. And overall, the solutions come down to what's called a collective action problem, where in order to really solve the tragedy of the commons, we have to come up with a mechanism that coordinates the activities of multiple individuals, because we probably can't get around this resource limit. So we have to find a way to say A gets to use the resource today, B gets to use it tomorrow, but they can't ever use it simultaneously or whatever. And so we need to come up with solutions that are so-called collective action problems. And those often involve getting government involved or some other higher player. And so that's kind of lessons we can take about generic tragedy of the commons that apply to copiers, that apply to fisheries, that apply to anything that has this structure where you have a resource that's non-excludable and rivalrous. All right, so any questions about the tragedy of the commons? We're gonna, I think, talk about the copier example specifically, but I just wanted to provide a context so that really this whole article wasn't about copiers. It was using a copier as a model for tragedy of the commons, but also a model for how we can use these archetypes to gain more insights into systems. Okay. All right. All right, so this whole article said that we can use these archetypes in 4 different ways, and Gesundheit. And so we're going to focus on each one of these here to sort of kind of drill down to figure out what the heck they were talking about with these 4 different ways. And the first way was this structural pattern templates. And so had this, I think this showed up on the reading assessment, where the idea here is we draw these complicated causal loop diagrams, starting with a bunch of variables, and then we turn those variables with links into loops, and then we turn those loops into patterns of loops, so that although the causal loop diagram behind it all looks pretty ugly, when we zoom out enough to forget about the variables, we start seeing patterns in the loops that tell us that despite all the details, fundamentally, this is a tragedy of the commons, for example. And so, you know, this, like, if you were to look into your system, and after you draw all of the circles around it, you might notice that you get 2 balancing loops with a gap in between them, a common gap that they're both trying to close. One that's closing it by raising performance, one that's closing it by reducing the goal. And so if you see that, I'd say, you know, that's a drifting goals. Whenever we see drifting goals, there are potential problems that can occur here, and we might want to deal with those problems ahead of time. So seeing this pattern might be a red flag. So we can, hopefully these templates help us, you know, filter out the details and notice fundamental problems in the way our systems are set up. All right, so that's what I mean by structural pattern template. So any sort of questions on this basic approach of structural pattern template? Clear, I mean, it's just sort of a way to make sense of the complexity of all these variables. Okay. Now, what I thought was a more nuanced perspective, and I really love this metaphor, is using these as lenses. So I like to talk about models as lenses like they're microscopes. And so when you look down through a, when you look down at, you know, a slide in a microscope, you can focus at different levels. And as you're focusing at different levels, you're seeing the same system, but you see a very different perspective at the system. And you may see totally different problems, even though it's all the same system. So what we mean by looking at using them as lenses, it's a way for us to filter out a bunch of distracting muck so that we can sort of see what's going on at one level at a time. And that's why we can possibly apply, just like you can focus on different depths in a sample in a microscope, you can use different lenses on the same system. And so this is where that copier example came into play. And so we had, and the focus here wasn't so much, I noticed in the perusal, some people focus on the copier specifically, and we can talk about copiers, but the focus here was really on this idea of the rush job, that there are certain departments that were not getting their copies quick enough. And so they implemented rush jobs, or when you put in a copy request, your copy request would go to the top of the line or the front of the line, and then that would get it in there first. And whether that was a good solution and what sort of other problems were created by that. So when we think about the rush jobs and we think about lenses, we can go back to the tragedy of commons. So how are the rush jobs like the tragedy of commons? Remember, tragedy of the commons, we're looking for non-excludability and rivalry. So how will rush jobs create a tragedy of the commons? Anybody have any thoughts on that? Yeah. Okay, so that sounds like you're saying that that rush jobs have the feature of non-excludability because anyone can put in a rush job at any time, right? What about rivalry? How are rush jobs? Anybody else have to say? So we got non-excludability. Where's the rivalry in rush jobs? Yeah. Okay, that's well said. So the comment there was, if someone puts in a rush job and they go to the front of the queue, everybody they get put in front of that was going to wait, an hour for their copy job now has to wait an hour and a half because somebody's been put in front of them. So it's a rivalry. There's rivalry between them, and that whoever uses the rush job is going to increase the time it takes for anyone else who already was at the front of the queue, who now might have got deprioritized, and anyone who's not at the in there as well. So there's a natural non-excludability and rivalry, which tells us ahead of time that we might have a tragedy of the commons. And so we can then think about the copier activity in terms of this guy here, is we can say that the more rush jobs a department puts in, the faster they'll get their copies back in the short term, which means next time they're going to put in more rush jobs because, hey, that works pretty well. So each department is going to keep putting in more rush jobs. As more departments make rush jobs their default, then the total number of rush jobs is going to go way up, which means the benefit to putting in a rush job is going to go way down. Eventually, everyone puts in a rush job, and it's as if rush jobs don't exist. It's just a formality at that point. There's no prioritization. And now we're back to the exact same situation we started with, thus the tragedy of the commons. So if we think about tragedy of the commons, there's all these guidelines. So we have to think about, well, if we really do have a tragedy of the commons, then in order to solve this problem, maybe we need to think about how you'd solve it on a freeway. On a freeway, maybe you put meters in so that you can't get onto the freeway as quickly at rush hour. Or in a fishery, again, maybe you charge fishing licenses. So you could say, maybe I charge for rush jobs. You want to put a rush job in, that's fine. You have to bill it to your account. So they're not free anymore. Maybe there has to be a third party. I need to hire somebody who is going to triage the rush jobs and say, actually, you don't need this as a rush job. Your request for rush job is denied, where someone else's will come through. And maybe that will reduce the total amount of rush jobs and maintain the quality of the rush jobs. So you can imagine that these are things that are effectively reducing the non-excludability, in adding the exclusiveness to rush jobs. That might be a way that we'd solve it. So once we recognize rush jobs as a tragedy of the commons, it helps our mind move into possible solutions. Not necessarily good solutions, but at least possible solutions that we know would potentially reduce the problem. So that's the tragedy of the commons lens. Are there questions about this perspective? Does everybody see how the rush jobs create an open access resource that has a concomitant tragedy of the commons that goes along with it? Okay. Questions online? Okay. Now they said that, just like a microscope, I can look at it at one depth. I can also shift, and I can focus using a different lens on a different aspect of the problem. So I can say, not only did this look like a tragedy of the commons, but it kind of feels like a shifting the burden problem, kind of similar to those traffic examples we read about in Moorcroft. In other words, in this top loop, we have a symptom here, which is nobody's getting their copies fast enough. So we come up with a symptomatic solution, a solution for the symptom, which is, let's just do rush jobs. You need your copier fast enough, just tell me, and I'll just take care of it. So then that way it can be rushed, and then that way that solves the problem for each individual department. And that seems to be a good way to fix the problem. It's very event-oriented. But if you really think about it, wouldn't it have been better for us to ask the departments, do you really need this many copies? Why is this copier resource so important to you? You know, is there a way for you to say, maybe send an email instead, send a digital version? Do you really need the paper-based version for this? And that mentality kind of is the fundamental solution to this problem. And maybe over time, if the problem existed for long enough, then each department would start saying, you know, it takes too long to print things out, just send me a PDF, it'll be fine. But because we've given them the rush jobs, we've now have the side effect of reducing the motivation to do something other than the rush jobs and the copier. So so now people are going to still keep using the paper-based solutions, even though a more fundamental solution might have existed out there to shift away from paper. So this is another way to look at it. So you could say, well, like, which one's the right perspective? Well, you'd say, well, I'd say if we need paper, for all those times we actually do need a physical paper copy, this is the lens that makes a lot of sense. So like, well, when you do need to print out the paper copies, those 100 pages of your mortgage documents or whatever, then this is how we need to deal with that. We have a tragedy of the commons. We have to decide who's going to get priority and whatever. But we also need to recognize that if we just give rush jobs to every single person who wants to print something out or copy something, then we're going to reduce our company's ability to shift away from paper when it doesn't actually need the paper. And so that's the perspective that we have here. And so those two lenses suggest two different suites of solutions. And so this focuses at one layer and the other one focuses at another layer. And that provides these two options for solutions that when we can go and try and see how well they work out. So that's what we mean by using these as lenses. So I just want to emphasize there's no one right archetype. There are some archetypes that are probably totally wrong, but there might be several archetypes that fit a solution. And we can learn something about a problem by fitting different archetypes to it. And even the ones that don't fit, we can ask, why doesn't this one fit? Oh, it's because it has this link that doesn't actually exist in our real system. Do we maybe need to add that link to our real system? Or maybe our real system is better because it doesn't have that link, even though the archetype has the link, and so on and so forth. So that's what we mean by using archetypes as lenses, by trying on different eyeglasses. So we've got sort of all of our different types of eyeglasses here, where we can kind of, it's kind of like imagine different eyeglasses for each one of these archetypes. And every time you look at a problem, you could say, do we have a drifting goals? It's like you putting on your X-ray glasses and looking at it and then say, okay, so then we don't have drifting goals. So do we have escalation? And you're like putting on your UV glasses or something, and so you can try each one of these and then you see what picture comes out. And sometimes you realize, wow, we do have fixes that fail here. Now that I realize that we have fixes that fail here, then I can start saying, well, what are the guidelines for dealing with fixes that fail? All right, so questions about that? Is that pretty clear what we mean by using archetypes as lenses? Eyeglasses. Yeah. Excellent question. So the question was, do you need to memorize all these things? And for the most part, I will, if you look, I've actually got sample midterms and finals online. You may have to do a little, there's like a little Respondus test thing that you have to do to kind of show that your machine uses Respondus. Once you've done that, you'll get access to the midterm and the final unit. And you can look at my samples, and I often give this or a version of this or something that maybe has some of these as like a built-in cheat sheet. There are some of these that I definitely want you to know that like limits to success, limits to growth. That's the S-shaped growth. So there's these fundamental ones that we talk about over and over and over again that I want you to know. But these ones that get like more complex, I'm not going to expect you to be able to draw these things out. But I might describe a problem to you on a midterm, give you this cheat sheet, or maybe a sheet that shows you, like if I go back, I think I had the one that shows kind of little cartoon versions. I think it was back here. maybe I should, yeah. So I could give you like this, that has kind of these little cartoon versions here, where if you just came into this class, with fresh, without actually going through the lectures and things like that, then you may not be able to interpret these things. But hopefully, after you've gotten up to the midterm, then even with a little bit of information that's on here, you'll be able to sort of tell the difference between drifting bowls and escalation. And so if I give you this on a midterm and then describe a scenario, I might ask you, well, what basic systems archetype do you think this fits? And then what of these particular solutions do you think might sound like that archetype would suggest that you should try? Does that make sense? Okay. Yeah.
For testing stuff, I do say earlier that it's a lenses show different things. We won't be looking for specific lens for a question, or is it more about the argument? We argue why we're using this one. Like, you see what I'm saying?
Well, so the question was, if I were to ask about lenses and there were multiple lenses that could be applied to a problem, then would you be able to argue for one lens over another lens? And I would say, at this point, the midterm is, whatever, a month off or something, or maybe a couple, 3 weeks off or something like that. I reserve the right to maybe ask you to engage in that sort of argument, but most of the time, I'm not going to try to get you into sort of an ambiguous trap. So if I'm looking for something particular, like, it'd be more likely for me to say the copier example fits two lenses fit the copier example pretty well. Which one of them is most closely associated with a symptomatic solution, not addressing the fundamental problem or something like that? Does that make sense?
Yeah.
Okay. Any other questions? Yeah.
Do you have like the different ways to apply the systems archetypes? Because in my head, they kind of like blur together, like you're using like different lenses.
Right. I appreciate that. Yeah, I would say that the nuance in the between these is something that I would kind of lean on. I mean, I'm not going to dwell. It's it's probably a little premature to be talking about the content of exactly what's going to be on the midterm. It's not like next week or anything, but since we're going there, like I wouldn't imagine more than like a question or so on this sort of thing, and I know there is nuance in like telling difference here, but that's kind of part of the challenge of the course, is that you come out of the course being able to tease out that nuance. And so I recognize it's hard now, but I guess it's supposed to be hard. And so, but I promise I'm not going to try to trap you in a trick where I'm saying, was this a tool for predicting behavior, or was this a dynamic theory? And be careful about your answer. I think that that's not of any use for me or for you. But it's more the fundamentals of being able to know how the dynamic theory thing works. The fact that you start with one theory and then that suggests how you can make changes to it, or the fact that we can imagine scenario planning. I think, I don't worry so much about the definition of structural pattern template versus lens, but use these 4 categories to sort of to identify what we're doing. Like, as I go through examples in Moorcroft or whatever, you can say, oh, wow, we just use that as a lens. Or, oh yeah, so we just predicted a bunch of behaviors that could have come out of this system. Or, oh, we didn't predict a bunch of behaviors that could have come out of the system, but we identified that the system has a certain dynamic structure. So based on that dynamic structure, we're going to try to add a link that wasn't there before, and so on and so forth. So more use these as a lens for looking at the material that we're going to cover from here until whenever the exams are. All right, other questions? Definitely not about exams. Okay. All right, so let me see if I can jump ahead here. All right, so now dynamic theory. So I'm just going to hint at that. This is something that we'll see a lot in the Moorcroft textbook, because it's really all about simulation. So this is where we kind of get into that. And the idea behind dynamic theories is we can try to explain things that appear to be random using the underlying structures as a guide. So they had this example of an email system, but I would relate back to what we did on assignment B2, where we had Betamax versus VHS. Two different systems, apparently equivalent. The one that kind of got a foothold earlier was the one that took over. And they had the same example, but they used it. And so this follows the so-called success to the successful archetype. This is related to competitive exclusion in ecology, for those of you who've taken sort of ecology courses, but certainly it applies to a lot of markets as well, where you've got two things that are competing for the same niche, and the one that either slightly more efficient or has a little bit of a time edge takes over. And so their example was these email systems. You have an old email system and a new email system. And so you really need buy-in for everybody to convert over to the new system. But they seem to, despite all the features that you claim exist with the new system, they just keep sticking with the old system. They just don't do it. And you're trying to say, well, why don't they switch to the new system? Well, they have no reason to switch to the new system. There's so much inertia in the old system. So this is a core theory for what the heck's going on. It might seem random that they all just coalesced on the old system. But when we actually then sketch it out, we realize that we have the success to the successful archetype here, which is a dynamic theory about once things have started, how likely is it for something else to kind of take over? And this is suggesting that it's not very likely. Now, once we've had this core dynamic theory, if we buy into this is what's going on, then we would predict that we can make a modification, if we can make a modification to the real system, which implements these links, one of this link up top or this link on the bottom, then we can break up the success of the successful archetype, because we're going to end up adding a balancing loop, which starts pulling the system towards the new system. So I'm not suggesting we know how to do this yet, but now we actually can propose a concrete challenge to the IT team. So we can say to them, you have a success of the successful archetype going on here. You've got a dynamical system that is latched into this old system, and there is no way you're going to get out of that basin of attraction there. If you really want to switch the system over, you need to poke a hole in this sort of basin that they're stuck down in. And you can do that by creating a link where the usefulness of the existing email system, for however useful the existing email system is, you will actually get more usefulness out of the new email system. Or if you use the existing email system, you'll actually get, again, more usefulness out of the new email system. So this might mean, for example, that we're going to automatically import all of your old email into the new email system. Or that lag that you experience on the old email system whenever you hit send, you're going to get less of a lag over here. So now, if you're sending email with the old system, it's going to be even better with the new system. So this actually creates a direction of improvement. If the new system has a completely independent set of features than the old system, we can't ever expect people to switch over because they've gotten used to the old system, and it's going to be a major adjustment process to get into the new system. So now we actually have a sort of something, again, we don't know exactly how the IT team is going to do it, but we know that if the IT team doesn't create one or both of these links, then we're going to stay latched in the old email system until they just get rid of the old email system, which maybe you need like 80% adoption of the new email system before they're willing to get rid of the old one, for example. It's not how it worked at ASU. They just drop the old one. But at other companies, maybe they'd actually think about the uptake before they just dropped it. So that's what we mean by a core dynamic theory and an extended dynamic theory. And from this theory, it's really a hypothesis. From this hypothesis, then it suggests an experiment, that the IT team could do that would predict that once they implemented these links, you'd start getting a lot more adoption, and that would test this out. If that prediction didn't hold up, we would reject this hypothesis and go back to the drawing board and say, all right, so maybe we didn't have the right core dynamic theory. what could actually be going on, and let's figure out how to intervene there. All right, so any questions about this basic idea of using core dynamic theories to understand the way systems are, and then extending them to understand the way they could be? Questions online? Okay, so then the last one, tools for predicting behavior. This is similar to this dynamical theory thing, but you actually have those behaviors over time that are involved. So the idea here is you have a simple process, like you want growth in a company. And so your assumption is that your future behavior is going to be exactly like, so our assumption is here that our behaviors of the system are determined by the internal structure of the system. And so if we model our system as just a growth loop, then we would expect that growth loop to just keep on growing forever, because that's what the kind of model behavior would be. So we had past growth and we're going to get future growth. Now this internal perspective, that's what we call the endogenous perspective. We've been using that kind of term here. Now, but this, this forecast here, we kind of know from these archetypes that there's never a growth loop in isolation. Every growth loop is going to have a limiting loop next to it. And so there will realistically eventually be some limitation. Even in global warming, eventually things get so bad that the temperature levels off. The temperature of the Earth can't climb to infinity. It eventually will level off. When it levels off is really the interesting question. It's probably not going to level off next year. So, we probably should worry about it. But, and then likewise, a company is not going to grow forever. It's going to level off, and it might level off next year. So for a company, thinking strategically, they need to plan for eventually their growth will level off. And that's what's kind of here. Now, and this is a very common thing in companies here. I beat up on Canvas because I like to beat up on Canvas. And so like on Canvas, for example, it starts out marketing to high schools or whatever, classrooms of 2 or 3 students. And they come up with a product that ends up working pretty well for their tiny little niche. And they grow. And they develop new features for that. They added quizzes and discussion boards and whatever, and things are going fine. Then they start realizing that they need more people to deal with all these customers, and they need to sell more to new customers. And they start investing in more sales team, but eventually they stop hiring developers, and they just invest in sales. They just invest in management. And what ends up happening is you end up getting a product that stagnates with basically the same set of features that it's had for the last, 15 years. And all of the growth being in the sales group instead. And so that is going to limit enthusiasm of your product. And that can be a problem when you look into the future. So tech companies that manage to continue growth are those that manage to keep their investment in development as well as sales and marketing. Whereas others, what's inevitably probably going to happen? ASU is eventually probably going to switch to some other learning management system and have the exact same problem, because nobody really cares about continued development in learning management systems. And so you end up getting the next great one comes into play, you switch to it, it stagnates, and then you switch to another one, Blackboard to Canvas to whatever else. So this is a very common pattern. And if you just are counting on your company always growing, then you're probably going to end up failing. Whereas if you're going to have this limitation coming up, then maybe you can change your investment strategy to either try to grow, have more efforts towards development, or maybe you back off some things to arrive at the new reality where you can sustain yourself without growth. So that's what this template here, limits to success or limits to growth, is an example where once we recognize that this is always going to be there in every single growth group, then we can better plan for these behaviors over time. So we don't want to get into the point where our efforts are going to explode while our performance levels off. So if we prepare for it early enough, then maybe we can have a more sustainable outcome. So that's another way we can use these archetypes, is to help project possibilities possible do scenario planning into the future. All right, so that's, other examples of that. So limits to success we talked about here, fixes that fail. That's another example where in the short term, it looks like we've solved the problem, but we can use fixes to fails behavior over time here. And we end up seeing that we get a different sort of predictable trajectory. So I bring it fixes that fail up here because both of these have a reinforcing and a balancing loop. This one's got the balancing that kind of happens first and the reinforcing second. This one's got the reinforcing that happens first and then the balancing second. And so the big difference between limit success and fixes that fail have to do with kind of this central variable here. When your performance is low, the balancing loop really doesn't kick in. It only kicks in at high performance levels. So when your performance is low, it's all growth. But here, when your symptoms are small, then really the balancing loop is what's kicking in. And it's not until the symptoms, when they get large, the reinforcing loop starts to kick in. So, so that's why this ultimately has got unimpeded growth of the problems, where this has got a tapering off of the performance. So the ordering does somehow matter, even though it looks like you have the same loops. All right, so any questions about either the comparison of these two or generally this idea about trying to use archetypes with their associated behavior over time to predict, if you're currently at a certain time, what are the possible futures that could happen if your system is well designed, defined by this sort of dynamic theory? That makes sense? Okay, so I think here I just focus in again on the fixes that fail and the contrast between fixes that fail. And then there's other examples here where we've got, I think my point here is that I want to contrast escalation with drifting goals. And so like in escalation, I've got two balancing loops, and notice that in the two balancing loops, there's kind of two different goals that are fighting against each other. We have a party over here that has one goal, a party over here that has another goal. The inside of the house wants it to be warm, the outside of the house wants it to be cold. These two things compete, and that's what gives you escalation behavior. I can contrast that, so that's escalation. I can contrast that with drifting goals. Drifting goals is two balancing loops. But notice that there's sort of one central performance gap that we're focused on, and that's what links them. And so here, I've got the balancing loop on the bottom is trying to raise performance up to the goal, but the balancing loop on the top is trying to lower the goal down towards the performance. And so I get a very different behavior over time. So if I go back to the escalation, the behavior over time that I expect is that I get the efforts of both parties end up growing forever. Contrast that with drifting goals, and I see actually here the performance over time declines toward a much lower performance than we started. So it's nuanced, but it's kind of where this central gap is. And so sometimes it's not enough for us to just know there's two balancing loops. We have to kind of know. That's why it's nice to annotate these loops. And so if we know we have two balancing loops trying to balance different quantities, it's probably escalation. If we have two balancing loops trying to balance the same quality, then we run into the risk of drifting goals. So that's the key difference between those, even though they look really similar. So questions about those two, like escalation versus drifting goals, or fixes that fail versus limits to success? Yeah.
So like just based on the structure of both of the loops, you can't tell when it's like do more to it, like because they have the exact same structure, right?
They have very similar structure. So yeah, so not just knowing that they're two balancing loops isn't enough. I don't need to know all the details, but I kind of need to know if they're both balancing the same thing or if they're trying to balance other things and are just coupled. And so I don't need to know every variable, but I kind of need to know, is there a performance gap they're both working on simultaneously? That's drifting goals. Or in escalation, notice this threat to A, threat to B. That's another way of saying there's a performance gap that's important to A, that's different than the performance gap to B. So this is the difference from the temperature inside the house. I want to bring the inside of the house up to 70 degrees. But outside the house, nature wants to bring the house down to the ambient temperature, whatever, 49 degrees. So nature is trying to work on one closing. It's trying to close the gap to 49 degrees. Inside the house, I'm trying to close the gap to 70 degrees. So they're working on two different gaps here, and that's what creates the escalation behavior. So do I have one gap or two gaps? Which is why when we're drawing our causal loop diagrams, and this is why Moorcroft always does it, usually doesn't just put a balancing, he usually puts a little annotation up top here, which kind of gives you a hint of what's going on in that loop. So I don't need to read all the details, but I can kind of see, are these two loops working at the same goal, or are they working at different goals? Does that make sense? Okay. Any other questions about these comparisons of these? And a lot of these, you probably, if you've taken SOS 220, you don't have to take SOS 220 to take this class, but if you have, there's probably a lot of overlap between these and some of the things you cover in 220. All right. So, I mean, that's basically what Kim and Lannon wanted to cover. These 4 different ways. They're arguing for why we should be using systems archetypes when we're doing strategic planning. And they're saying that if we know all these, then we can take a giant cobweb of causal links and look for patterns of loops. And that's really useful because then we can, with patterns of loops, there's patterns of problems. Then they also say that, that we can, instead of starting with the cobweb, we can start with the pattern templates. And we can ask ourselves, do we have one of these pattern templates here, and use that as a lens? And we might find we have multiple lenses that fit, but they highlight different sort of colors of the problem. And so, so that ends up helping us to guide us to find the right questions. The other thing we can do is to create dynamic theories. We have behaviors currently at our current time that we don't understand. And so rather than assuming that they're just random, we actually build a model that has the same behaviors that we see in our current time slice. And from that model, it gives us latent variables that, by latent variables, I mean they're hidden. We normally can't see them, but we know that they're underneath the water, actually doing all the work. And from those theories, it proposes interventions, ways to manipulate those latent variables in ways that, that potentially can solve the problems we have. And then that's about all the current stuff, and then also for the future. So if we know what our latent variables are, then we can take all those latent variables, look them up in our pattern templates, and say, for this pattern, what are the possible things that could happen in the future? And are we prepared for all of those things? There's probably never going to be growth to the sky. So are we prepared for eventual limitation? Do we have an idea of when that limitation will come? And when should we start reinvesting to deal with that limitation? And so on and so forth. And those are 4 distinct ways that you can make use of these system archetypes. And this itself is just a way to kind of market the idea of using these system archetypes. Now, the bigger picture for me and a sustainability scientist is just generally wrapping our heads again around the sort of science of thinking about complex systems. And so if we ultimately want to design interventions to make the world or a particular organization a better place. And how does that work? Well, we map out the intervention. So we can break a link, add a link, shorten a delay. These are all things that once we've wrapped our head around the problem as if it was a causal loop diagram, then we have different interventions suggested by the causal loop diagram. From there, we can use simulation tools that we're going to learn about in Unit D, our next unit, to predict what will happen given we've made these changes. And then from those predictions that come out of our simulation tools, we can compare. And so this is kind of what I'm saying here is if we can't do experiments in reality, we can do them in the simulation. That's what I was trying to say here. And then from those experiments that we do, compare to kind of our predictions of so we've got, from the system archetypes, we get predictions. From the predictions, we can compare to a real experiment. And if the real experiment doesn't match the predictions, then we end up reforming our hypothesis and doing this all over again. So we form a hypothesis, we make a prediction, we test the prediction, and then ultimately reform our hypothesis. And this is what we mean by sustainability science. Complex systems are not, we're not studying, a wetland or something like that. Wetlands are complex systems too, but we are largely studying human natural systems, coupled human natural systems, human organizations, humans working together, things for which we don't give you an ology that you go and study. So you don't take, coupled human natural systems 101. You largely have to build the knowledge of these systems on your own. And so as a sustainability scientist, this is what you're going out and doing, is you're forming hypotheses, not about natural systems, but about coupled human natural systems. And from those hypotheses, trying to predict what might happen. And that's why you get simple models that allow us to make these predictions, do experiments on the real world, and then update the knowledge we have about these novel systems that wouldn't have existed without the human enterprise bringing these things together. So, a wetland exists on its own. A building like this one doesn't, we understand we can run, wetlands will be here long after human society is gone, but this building won't be. And so in order to understand this building, we don't have billions of years of evolution to look back on to understand how natural systems work. This building has a much shorter lifetime, and we don't have the textbook to understand this building. And so to understand how all of these different pieces that we put together in novel ways work, we have to do our own science. And that's what we really mean about sustainability science. It's not just a subset of biology or ecology or whatever. It's a totally new thing. It's a totally different thing where we're trying to understand systems that don't exist in nature by themselves. Okay, so that's, I think, most of the message I have for you. So any questions about any of that? Okay. Questions online? All right, so from here on out, we're going to go back to the Moorcroft textbook. So chapter 3 is due before lecture D4. That is in a while. This is the last lecture of Unit C, which means on Tuesday, I start lecture D1. So D1's Tuesday, D2 is Thursday, and then D3 and D4 are the next week after there. So you got basically 2 weeks to deal with that reading. We are going to start simulating things, actually stock and flow diagrams, generating our own behaviors over time. You can use VinSim for that. If you've been liking VinSim, that's fine, just keep using that. If you want to try something new, then go ahead and go to insightmaker.com and create a free account there. And that is an alternative tool. You don't have to do it, but if you don't like VinSim, this is my alternative for you. So every example I will do an example in VinSim and in InsightMaker, so everybody knows how to use both, but you don't have to use both. So yeah, we'll start seeing math. So because we're now starting to project behaviors over time, we're gonna have to start writing little expressions where we have to actually mathematically model the relationship of one variable to another. Not really a lot of calculus, just a bunch of arithmetic really to pull things together. Then kind of looking farther out, after lecture D4, we will have the midterm. So that's, like I said, roughly like 3 weeks out or so, that you can look online for the precise date. There are practice problems and solutions available on Canvas. I will have the midterm will be a 2-stage exam on a Thursday. The Tuesday before that, I'll have a review session where we'll just go over sort of all of the pre-midterm material and take questions. And it could be all questions. We could work problems all day if you'd prefer. And then we'll have stage 1 of the exam, which will be 80% of your score. And I won't give you solutions or scores. Then you come back for Tuesday and we'll have stage 2, which will be open book and open collaboration, where you all can work together on the exact same test. And that will be 20% of your score. So I'll remind you of this as we get closer to that. Other shorter term reminders on Sunday, you got the muddiest point for this week. And then you got that assignment C1 that we started, where you're drawing a limits to success. And then you're drawing a drifting goals. And then in the third one, you're just drawing a loop or a system with 3 loops. And if you want, you can take one of your systems from the previous part of the page and add a loop to it. It just has to be plausible. All right, so that's all I've got. So any questions about timeline going forward? We have a few minutes left over, so if you want to hang around and work on your assignment C1, I'm happy to answer questions or help with that. Otherwise, let's do the attendance exercise. Online, it says the assignment says assignment C1 is due on Wednesday. I thought I double checked that and said it's due on Sunday, but it is due on Sunday. That's the intended date. So go with these here. It's a short assignment, so I'll update that if that's not the case. So the attendance question here is, what is the name of the system archetype with 2 balancing loops that is not limits to success? So limits to success has 2 balancing loops. I'm sorry, not balancing loops. I'm sorry, I didn't mean to say not limits to success. That is not escalation. So what is the name of the archetype with 2 balancing loops that is not escalation? And there was a question online. We don't, for assignment C1, we don't need to write any descriptions on the graphs. Unless I don't want to, if I say on the assignment, write like a caption, then do that. If I didn't say to write a caption, then just the diagrams are fine. I forget how I phrased it, but if it doesn't say to not write a caption, then just the diagrams are fine. But do put it all in one document, like question 1, question 2, question 3, so that it's easier to kind of grade in one jump. Yeah.
So for the assignment C1, the one that we did as like a group, is that the one you meant? Okay. So that one, like the one we did on Tuesday, that's part of it? Like the
Yes,
first part of
yes.
it? Oh, okay. So then we're allowed to use that for like the next one. Okay.
Yep. Well, yeah, so you can use that for like part 3. Part 2 is different, but yeah, but the things you do for part 1 and part 2, you can co-opt for part 3 if you want.
Okay. And this was the part 1, right?
That's right.
The group one?
Yeah.
Okay. Thank you.
Let me make sure there's no questions here, and then let me end this and I can take your. All right, so I'm about to end the meeting here unless there's any more questions online. If not, have a good weekend and we will see you on Tuesday.